The basic idea of random errors versus systematic errors is this. Random errors are just, if you measure, there's going to be random errors. What percentage of errors are going to be bigger than the actual value? And what percent will be smaller than the actual value? Just if it's totally random.
50?
50-50, right. So it's just as likely to be too high as too low. The good news about that is that when you average a bunch of random errors, it comes out, if half of them are too high and half of them too low, they come out to be just right. Random errors you actually can eliminate by averaging many trials. Systematic errors, though, that's when you measure the same amount or same fraction in the same direction in error every time. So if your ruler is 0.5 centimeters too short, you might measure things off by 0.5 centimeters every time. If it's the same error in the same direction every time, that's what we call a systematic error. In other words, every measurement we do is wrong by the same amount. So let's try this. Errors which could result in a measurement either higher or lower than the true value. Blake, can you help me with that one? What would this one be, systematic or random? If it could
Random.
be either higher or lower.
That'd be random.
You got it. And errors which are always in the same direction for every measurement.
Systematic.
That would be systematic. So that's the basic idea. Now we got to figure out what these all are. If you don't calibrate your scale, what calibrate means, does anybody know another word for calibrate? It starts with a Z.
Zeroing.
Yeah, zeroing. You got to zero your scale. That's with spring scales. That's with any kind of weight scale. Anything you got to calibrate. You have to calibrate a ruler too. The way we calibrate a ruler is by putting the end of whatever we're trying to measure at the 0 point on the ruler, which may not be the end of the ruler, by the way. That's calibrating your ruler. For this one, if you don't calibrate it, here's a great example. Let's say you didn't know this, but when no one was on the weight scale in your bathroom, it read 5 pounds. When I get on it and I read 155 pounds, turns out that's not right. How far is it off by?
5 pounds.
5 pounds. But when my wife gets on there and she's like 100 pounds, but it says 105, notice it's always off by the same amount if it's miscalibrated. So that would be a systematic error. If you don't calibrate or zero a scale, you're always going to be off by the same amount. Systematic errors, the only way to fix them is by zeroing your instrument or calibrating it. Now, if you are doing many trials, which form of error will cancel itself out when you average all those trials? The answer there would be random error, because since half of them will be too high and half of them will be too low on average, averaging all of your trials will give you the best result, which is somewhere in the middle. Does that make sense?
Yeah, it does.
Okay, cool. Did you get stuck on the next part?
The part after the table. That's how it's
Okay,
confusing.
after the table. Which of these could result in random errors? So the question is, which of these are things that you could either measure it as too high or too low? And it can't be in one direction. If it was only in one direction, it would be a systematic error. If you lined up the object with the end of the ruler, which is not always the 0 mark, that means that if I'm measuring something and I line it up with the end of the ruler, but the 0 mark is not on the end of the ruler. So if I lined up this thing with the end of the ruler, that would be a systematic error. Every one of my measurements, it would read too short, because it really should be at the 0 mark, which would be right up there. Lining up the objects with the end of the ruler, would that be random or systematic? What do you think on that one?
Systematic.
That's systematic, so I can't check it. That will always be wrong in the same direction. It'll actually be too short by the same amount every time. Your measurement will. If you measure with an accurate ruler using proper zeroing, if you do measure properly, here's the thing. Is anybody perfect in the universe that you know of? Nobody is. Even if you have an electron microscope, there's still uncertainty. So if you're measuring with an accurate ruler, you're measuring everything right, you're still going to get some random error. You could measure too high or too low. Which one's more likely?
Neither is more.
Neither, exactly. So that's a random error. If you properly use a stopwatch, are you always going to be too high or too low, or either?
Either.
Yep, so that's random. You will sometimes have times that are too short and times that are too long, but you're not always going to have the same direction. Clock which runs fast, would that be random or systematic?
Systematic.
Yes, because it's always going to read a time that's too high. And a miscalibrated spring scale, also systematic, because it'll, whatever the zero is, if it reads 5 newtons with nothing on it, everything's going to be 5 newtons too high.